So today we're going to go over solving quadratics using the quadratic formula, which is your fail-safe method. Factoring doesn't always work. Most problems realistically aren't factorable. Square root property only works if we've got the nice setup for it, something squared equal to a number. We can always set it up for the square root property using completing the square, but we saw if b is not an even number, that gets ugly because you start getting fractions, you start squaring fractions, you start factoring fractions, and it just gets out of hand really quick. This is your method for solving a quadratic if you're not sure, and the directions say whatever method you want, method of your choice. So like on your homework, just make a note that on 31, 35, 39, and 43, the directions say to use any method. So this might not be the fastest, it'll always work, but we'll talk a little bit about picking out the best method. So using the quadratic formula itself is what we call plug and chug. You take the numbers, you put them into a formula, and you just simplify it. So the part that I find people have the most trouble with is the simplifying. So we're actually going to do as many examples just simplifying as we do examples of using the full quadratic formula. So there's two different methods we can use. I always use method 2. Method 1 actually comes from unit 2. So when we simplified in unit 2, we always factored, and then we could cancel common factors. I find people have a hard time with that, particularly with a plus or minus and a radical and all of that stuff going on. So we've actually used method 2 in the past as well, which is when you have a 3-term fraction, we just make sure you can divide something from all 3 of them. It's got to go into all of them, all or nothing. So the first thing you want to do is make sure that the radical can be simplified. If you can't simplify the radical, you know you're done for simplifying the entire problem. You don't even need to try anything else. You always start with the radical. So in this first problem, this is what my answer looks like after I use the quadratic formula. I want to just simplify it now to get my final answer. So you always start with the radical. So we're looking at the square root of 44. Seeing if we can break that down. If we can't, we're done. So do any of my perfect squares evenly divide into 44? 4, yeah. 4 times what gives me 44? 11. Now remember, when you break these up, and I think this is giving some people trouble, don't just write 4 times 11. It's the square root of 4 times 11. So what number comes out? 2. So I have 2 square root 11. So I'm going to go back into my original problem and just replace the square root with 2 square root of 11. Everything else is the same around it. But I know 2 square root of 11 is the same as the square root of 44. And now I have 3 terms there. We never divide out of a square root. I'm always looking at its coefficient. So I make this triangle. I'm trying to see, is there any GCF to all 3 of those terms? Yeah, because it's 2 times the square root of 11. It's just like having 2x. We can divide out of the 2. It's okay to divide out coefficients, yeah. So what's my GCF for all 3 of those? 2. I can divide them all evenly by 2. So what I'm going to do is I'm just going to go through, and and you don't have to write this part out. I'm just going to go through and divide them all by 2. So 2 divided by 2 is 1. Plus or minus 2 divided by 2 is 1. But 1 square root of 11 is just the square root of 11. So if there's a coefficient of 1 here, I don't necessarily need to write it. You can if you're afraid you're going to miss a necessary 1. But there's only one place where that is absolutely necessary. And the only time you need to put the 1 is if it's this first number. Because adding and subtracting from 1 is different than multiplying by 1. Multiplying by 1 gives me the square root of 11 still. But if I take something, I add 1 to it, I've changed its value. So this 1 I need to keep here. But if you also get the denominator as 1, you don't have to write it. So this is the only number 1 that's important when you're simplifying. So we're going to look at our radical. And then we're going to look for a GCF to all 3 terms in that triangle. So in the second problem, I'm going to move over to the right. We have x equals 9 plus or minus the square root of negative 18 over 12. the first thing you always simplify is the radical. If you can't simplify the radical, you can't simplify the problem. Devin. Yeah. So you could either say, okay, we look at this, we say square root of a negative number. I know I'm going to have I in there. I is always outside. I is never underneath. So when you run into these imaginary radicals, you may just start by saying that's the same as I times the square root of 18. If you just put the I out front, then you can get rid of the negative sign. Or you could start by breaking up as the square root of negative 1 times whatever else. It's really up to you guys. And then how am I going to break up the 18? 9 and 2. So you could either go negative 1 times 9 times 2, and it's still going to get your I out front. Or if you just put the I out front and then work with 18, 9 times 2, either way you get 3I square root of 2. So I'm just going to go back to my problem. X equals 9 plus or minus 3I square root of 2 over 12. And I'm going to use my triangle again because I need to include all three terms. It doesn't matter that that second term has an I. It doesn't matter that it has a square root. I can still simplify its coefficient. So you might not. Do I have a GCF to all three of those? Yeah, what can I divide them all by? 3. So all right, let's just go and divide everything by 3. So I'm going to have x equals 3 plus or minus. Do I need to put the 1 in front of the I? No. Maybe you can, but we don't usually. I square root of 2 over 4. Do you think that answer's done? What do you mean you gotta do the I? There's one thing I could do to this. You can't divide a square root with a non-square root. So think back to 10.7. When we have, this is a complex number. A plus bi. What did we do when we had one big fraction and there was an I in it? We separated it. So this goes back, and I don't have it in the simplified directions, but yeah, so we just did 3/4 plus or minus I squared root of 2. So when you see an answer like this in your homework, that's what they're doing. They're going back to 10.7 and they're writing that in the form A plus bi. But it's just if you have an I, make it 2 fractions if they're fractions. Now in the next one, we would have had a perfect square. We got 10. Do you think I can leave my answer like this, blob of a fraction? No. No, not if there's no I and no square root, it means I can simplify it. So this is the case like before we didn't have it as a fraction, but this is a case where I can split it up and simplify it into my 2 answers. So I can do negative 4 plus 10 divided by 3, and then negative 4 minus 10 divided by 3. I'm just using that plus or minus to split the numerator twice. So negative 4 plus 10 is 6 over 3, which is going to give me 2. And negative 4 minus 10 is negative 14 over 3, which I would just leave that as negative 14/3. But if you end up with a perfect square, you're going to have to break it up just like we did with square root property, just like we did completing the square. If there's no more radical, you split it because you can simplify it further. And how about the last one? What can I do to simplify the last one? Divide, I hear radical. What would you divide? All of them? You can't divide under a square root. What's the first thing we should look at? No, that's the last thing we look at. First thing, radical. Always the radical. You always start with the radical, 100% of the time. 15. Can I simplify the square root of 15? No. No matter how tempted you are to do anything else, just walk away. If you can't simplify the radical, that's it. Done. What's the number in front of the square root of 15? So this is the number that would go in my triangle. Because it's got to be that triangle. It's not just two of them. It's got to be all three of them. So the coefficient's 1, which means it has a GCF of 1, which doesn't get me any further. Questions? So the other way would be like in this numerator, the GCF is 2. So I'd factor out 2 times 1 plus or minus the square root of 11 over 12. And then I would simplify 2/12 to be 1/6. Yeah, that's why I don't do it that way. So you still get the same answer, but the factoring part doesn't usually work for people. So I just like the triangle. Any other questions? So your setup for the quadratic formula is very simple. You need to have your quadratic in standard form, which means it's equal to 0. The other thing you really, really, really need to pay attention to is which terms you have. A is always with x squared. No matter what order your problem's in, the x squared terms has the a with it. B is always with x. And C is a constant. So you may be missing, for example, the middle term. You might just have like 2x squared plus 10. That means B is 0. So it's A always with x squared, B is always with x, and C is always a constant. You might not have all of them, but they're still A with x squared, B with x, C your constant. So our only setup is that it has to be equal to 0. So it's the same setup as when we solve by factoring. Once it's equal to 0, it's good if you put it in the right order, descending order. We're just going to use our quadratic formula. We're going to plug all our numbers in and simplify. So if I look at my first example, so solve using the quadratic formula. So we're reading our directions carefully. If you do that extra little practice set of problems, you'll see all the different directions, all the different methods. So the first thing I need is to make sure I have my setup, which for the quadratic formula is just that it has to be equal to 0. So in Lemon 1 we had 2 different conditions, but the quadratic formula setup is it just has to be equal to 0. Now I want to find A, B, and C. These are the same A, B, and C as we've always used with trinomials. Same A, B, and C that we learned in Unit 1 for factoring. So what's A in this problem? 1. B, and C is 15. Now what I recommend whenever you're learning a new formula is that you always start by writing the formula in its general form first. So I'm going to write our quadratic formula as x equals negative b plus or minus the square root of b squared minus 4ac. Now this next part, I'll wait till you finish copying that, is important because it's one of the things that I take off points for a lot. It's the whole right side divided by. So one of the typical mistakes is that people just put the divide by bar under the square root. Start after the equal sign, and it's the whole right side gets the divide bar, the whole thing. And it's all over 2a. And it starts with x equal because we're using this to solve for x. That's what this magical formula does, is it tells us the values for x. So I have x is equal to Now we're going to substitute in our values. I always use parentheses, especially because there's negative signs in this formula. So negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 15, all over, so under everything I've written, 2 times 1. So I just take parentheses, and everywhere in there, I put in my A, B, and C. Now, the only other thing I find that people really make errors in, other than the simplifying, is finding what's called the discriminant. It's just the math word for everything that's under the square root. So you can, if you don't put the square root, enter this whole thing in your calculator with the parentheses. 8 squared minus 4, 1 times 15, and it will give you the number under the square root like that. You don't necessarily have to do this in more than one step. Without the square root, if you enter in your calculator with all your parentheses, 8 squared minus 4 times 1 times 15, you'll get that value under the square root all in one step. But I'm going to do mine by hand since you can't watch me type on a calculator. So negative 8 is out front, plus or minus the square root. 8 squared is 64. If you're doing this by hand or you're doing this in more than one step, you want to treat this as negative 4 times 1 times 15. You always treat it as negative 4. And then whatever sign it gets is the sign that goes in the radical. So that's a negative 60. So minus 60 all over 2. But if you tried that in your calculator, which I encourage you to do, you should have just gotten the number 4. And make sure you put it under a square root, but again, your calculator takes care of that all in one step. Negative 8 plus or minus the square root of 4 over 2. So are there any questions on how, again, that discriminant, that value under the square root, is the first place people tend to make mistakes? All right, now we got to work on cleaning this up, simplifying. Where do I always start my simplify? Radical. What's the square root of 4? 2. So we're going to just take the square root of 4 and replace it with the number 2. So I have negative 8 plus or minus 2 over 2. Did you have a question, Ayana, on the radical? Okay. What do you want to do next to simplify? There's actually 2 different routes you could take. Say it again. Okay, so you went right to, you did the plus or minus. And what did you want to do? You could do that. And that would simplify. You could also go ahead now and draw your triangle. So I always think of it the way Napoleon did, where I just see numbers and I separate it. But if you see your GCF, you have to simplify them either first or last. So 2 different ways would be to say, okay, Napoleon said, I'm going to just go ahead and do my negative 8 plus 2, negative 8 minus 2 over 2. And you got negative 6 over 2, but what's negative 6 divided by 2? Negative 3. And then you got negative 10 over 2, which is negative 5. And totally blanking on your name right now. Shakira. What Shakira said was, well, I see that those all have a GCF. So I'm just going to go ahead with my triangle and divide them all by 2. And when you divide them all by 2, you get negative 4 plus or minus 1, which when you break that up, you get negative 3 and negative 5. So you either simplify your fractions here, you simplify your fraction here, they come out to the same answer. So either way you go, you're going to get x equals negative 3 or negative 5. So any questions on the solving? Yes. 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 Do you have a question, Pauline? Now, if I had this question on a test and it said solve using any method, I wouldn't use this method. This always works, but I could have done this in 2 steps. First thing I would check for if A equals 1, and it's your choice. Now, if I tell you the method, you've got to use that method. But if it's your choice, like on these problems on your homework, I would look at that and say, can I think of a pair that multiplies to 15, adds to 8? Yeah. So I would personally solve this by factoring because I could come up with a pair, 3 and 5. If I write my factors, x plus 3, x plus 5, set them equal to 0, x plus 3 equals 0, x plus 5 equals 0, I've got my answers. A lot less work. So that's why I recommend that you maybe experiment with what ways you look at these problems because the fail-safe isn't always the quickest. So just keep that in mind. Yeah. Yeah, because then I put x plus 3 equals 0. Subtract 3, there's my x equals negative 3. I take x plus 5 equals 0. Subtract 5, there's my negative 5. Right, but this always works. This very rarely works. This very rarely works.
Now, how would you know? What if you decided to do it that way?
So, yeah, you could just substitute them back in and make sure that it equals out to 0. Yeah. So, just food for thought. It's not always the fastest. Quadratic formula always works, though. All right, in B, do I have my setup for B? No. Quadratic formula's got only one condition. It has to be equal to 0 to start. So I'm going to move the 3 over. Yeah, I'm going to add 3. So I have x squared minus 5x plus 3 equals 0. You cannot find A, B, and C until it's equal to 0. But now that it's equal to 0, I can get my A, B, C. So A, B, C. So A is 1, B is negative 5, and C is 3. So since A is 1, if I had a choice, I would do a quick, can I find a pair that multiplies to 3, adds to negative 5? But there's not one. So that method wouldn't work. I wouldn't complete the square because B is not even. I would use the quadratic formula on this. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So make sure your square root extends far enough. Make sure that your divide by extends far enough. So if the b is already negative, you take the negative from the formula, parentheses, and in the parentheses put your number in, which is also got a negative on it. That's why I recommend that you use the parentheses. So you got the negative from the formula outside, and then the negative from the b inside. And what happens when you have two negatives next to each other? What do they turn into? Positive. Yeah. Plus or minus the square root, especially if you're using calculator. I cannot stress enough to put everything in parentheses. It's a silly reason to get things wrong, is that you didn't use parentheses. All over 2 times 1. So now out front, we have the negative, negative 5, which turns back into a positive 5. So I have 5 plus or minus the square root. Again, you can enter the thing under the square root without the square root in your calculator all at once. It's called our discriminant. If you're working this out by hand, negative 5 squared is positive 25. And then treat this next part as negative 4 times 1 times 3. And whatever sign you get is the next sign that goes in your discriminant. So I have negative 4 times 1 times 3 is negative 12. And 2 times 1 is 2. So I have x equals 5 plus or minus the square root. 25 minus 12 is 13, all over 2. What's the first thing I try to simplify? The radical. Is there anything I can do for the square root of 13? Nope, so you're done. Don't even look any further. No radical, no simplify. But again, you couldn't get that answer from factoring. So sometimes factoring doesn't work. But if it does, and it's a shortcut, it can be quicker. All right, C, 3x squared plus 7 equals 8x. I'm going to solve using the quadratic formula. Now, another time that I always use the quadratic formula is if a is not 1. If a is not 1, I usually don't bother with anything else, unless there's an obvious GCF that will make a 1 easily. So setup for quadratic formula. Standard form of a quadratic is just that it's equal to 0. So what am I going to move? Okay, that 8x. But when I put it on the other side, where am I going to put it? In the middle. Descending order. You can put it at the end, but then you've just got to be careful that you go ACB when you pick out your ABC. So I just make sure it's x squared, x, my number. So I'm just gonna throw that guy in the middle. So I have 3x squared minus 8x plus 7 equals 0. A is always with x squared. It doesn't matter where it is in my actual expression. B is always with x, and C is always constant. Then I'm going to use my quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So go for it. Examples that needs more simplifying. So I didn't see any problems with putting the values into our formula. Remember, there is a negative in a formula, and then this problem also has a negative for the b, which just turns it back to a positive. And then we had the negative 8 squared minus 4 times 3 times 7 all over. I didn't see anyone shortchange their divide by. 2 times 3. So this is the first time we've had a that's not 1. The minus and negative turns to positive. This first term is always the opposite sign of what b is. That's what negative b means mathematically. So I have x equals 8 plus or minus the square root. So a lot of 64 minus 84s over 6, which is 8 plus or minus the square root of negative 20 over 6. And then I heard a lot of, oh, that's the I. I see the I. I got the I. So yeah, square root of a negative number, that's the I. That's where we get the I. And then the 20, I saw people got the 4 times 5. So the square root, which is always what we simplify first, is 2i square root of 5. So then I saw people went ahead and they said, okay, so I have 8 plus or minus 2i square root of 5 all over 6. This is a part where you've just done a lot of math and you're like, okay, is there something else or not something else? The triangle. The triangle is the last step in these. So look at your triangle of numbers not under the square root and try to divide a GCF from them. And I can divide these all by 2. So I get 4 plus or minus 1i, or just I, square root of 5 over 3. $1 million question. Separate them. It's imaginary. Well, yeah, 4/3 plus or minus I square root of 5 over 3. Now, D, we might not actually have time. We got like 3 minutes to go through all of D. D is a very common question that people miss because they're I would never use the quadratic formula on D personally. But is D in standard form? Is that the setup for the quadratic formula? Yes. Here's the trick. What are A, B, and C? What's A?
1.
What's B?
-6.
0. B always goes with X. Do I have a term that has just the regular X on it? No. And that's where people get this question wrong. C is the constant. Yeah. 6 isn't a perfect square. I mean, if so, let me just show you. If you do the quadratic formula, this is what it's going to look like. You're going to substitute in all your numbers, but you've got a bunch of zeros. So it ends up just being 0 plus or minus, which is plus or minus the square root of 24 over 2. And then the 24 you break up is the square root of 4 times 6. So you get plus or minus 2 square root of 6 over 2. And then you can divide out the 2's and you get plus or minus the square root of 6. How I would solve this? Any guesses? You can't factor the 6. Square root property. Add 6 to both sides. X squared equals 6. Square root, plus minus. X equals plus or minus the square root of 6. Square root property. So you can get something squared equal to a number and take the square root and you're done. Just like that. Much faster, much less simplifying.